In this video, I'm going to go over our first semester review assignment from the 2019-2020 school year. Remember, you can scan the QR code up here in the top right corner for more in-depth tutorials on all kinds of different topics that are covered in this review. Question 1 says, write the number 854,007,021 in standard form. So I'm going to start out writing 3 digits at a time. 854 will go in the millions place, so I'll go ahead and write that down, 854. I'm going to put a comma that will represent the millions place. Then in my next period I have 7,000, so I have no 100,000s, no 10,000s, and just 7,000s. A comma will represent the thousands place. And then in my next period I have 21, so I have no hundreds, and a 2 and then a 1, and I don't need to put anything after that because that's the end of my number. Question number 2, write the number 2,605,931 in expanded form. Expanded form is where we are pulling apart the number so that each digit pops out of its place value and says its name. So this 2 right here has a value of 2 million. We're going to add that to the 6, which has a value of 600,000. The 0 has a value of nothing, so I don't need to put it on there. The 5 has a value of 5,000. The 9 has a value of 900. The 3 has a value of 30. And the 1 has a value of 1. When I add all of these numbers up, I will get 2,605,931. Question 3 says write the number 3 and 900ths in both word form and expanded form. So in word form, this is 3. The decimal is read as and this ends in the hundreds place. So we read the entire, all of the numbers after the decimal point, and then we say the last place value. So this is 3 and 9. The last place value is the hundredths place. So there's your number, 3 and 900ths. In expanded form, the 3 is worth 3, the 0 is worth nothing, so I don't need to write anything, and the 9 is worth 900ths, so I'm going to write that as 900ths. I could also write this as 3 times 1 plus 9 times 100th. That's exactly the same thing. Question 4 says write the number 84 over 1,000 as a decimal in standard form. So this has no holes because this would have to be 1,000 in the numerator for this to be even one hole. So there are no holes, and then there are 84 thousandths. So that means 84 needs to end in the thousandths place. So we have the tenths place, the hundredths place, the thousandths place. We want the 84 to end in the thousandths place, and we need a placeholder right there. So there's our decimal, 0.084, which is 84 thousandths. Number 5 says write the number that is exactly 10,100,000 larger than 46,587,139. So first I'm going to find the 10 millions place, which is this 4 right here. And we're going to bump that up 1 because I want one more 10 million. So I'm going to make that a 5. And then I'm going to find the hundreds place, which is this 1, and I'm going to bump this up by 1 because I want one more 100. So my new number is 56,587,239. Question 6 says write in order from least to greatest, and then we have a whole bunch of numbers right here. So the first thing I'm going to do is stack all of these numbers up and make sure that I line them up according to place value. So here's my ones place just to the left of the decimal point. I'm going to make sure that all of them have that ones placed lined up, and I'll fill in some empty place values in just a second. This is where you really want to be neat with the way you write this out, because otherwise you could easily squish these numbers, these digits together, and then you would not realize that there really is a 0 there and some zeros here and all of these empty place values. So now we can start comparing from left to right. Of course, all of them have 3's in the ones place, so that doesn't help me. The next smallest is either going to be this one with a 0 in the tenths place or this one with a 0 in this tenths place. So I'm going to have to look at these two and go to the hundredths place. This one has a 7 in the hundredths, this one has a 2 in the hundredths. So this one is your smallest one. I'm going to write a 1 out to the side of this to remind me that it is the smallest number, and that would make this one the second smallest number. So now I'm ready to just compare these last three. Of course, they all had a 3 in the ones place. In the tenths place, this one has a 2, and those are both 7. So this is your next smallest. I'm going to call that number 3. And these two, I'm going to have to go to the hundredths place. A 0 is smaller than a 2, so this will be number 4, and this will be number 5. Now I just need to rewrite them. So my smallest number was 3 and 2 hundredths, this one. My next smallest was 3 and 72 thousandths. My next smallest was 3 and 2 tenths, this one. Then I had number 4 was 3 and 702 thousandths. And lastly, 3 and 72 hundredths. And notice that I checked these off as I wrote them down just to make sure that I didn't accidentally write any of these numbers down incorrectly. I was double checking as I was checking them off each time. That's a very common mistake that I see, that it's very easy, especially when they all have similar digits. It's very easy to accidentally write one down wrong, or even to just leave one out. Question 7 says compare using less than, greater than, or equal. So we have 30 hundredths and 300 thousandths. Well, over here I have place values all the way to the thousandths, so I'm going to make sure that I have place values all the way to the thousandths over here. And now it becomes clear that these two numbers are equivalent. B, I have digits all the way to the thousandths over here, so I'm going to do the same thing over here, put a placeholder there. Now I have a 2 and a 2 in the ones place, a 7 and a 7 in the tenths place, but a 6 in the hundredths, and 6 is greater than 0. So 2 and 76 hundredths is greater than 2 and 706 thousandths. Remember, just because a number has more digits does not necessarily make it a greater number. Question number 8 says use estimation and comparison to place the following decimals on the number line below. So the first thing I'm going to do is, I see the number line starts with a 1 and ends with a 3. I'm going to put the halfway point, and halfway between 1 and 3 would be 2. And then I'm going to go ahead and mark some other data benchmarks. So halfway between 1 and 2 would be 1.5, 1 and 5 tenths. And halfway between 2 and 3 would be 2.5, 2 and 5 tenths. I can fill in a few more data landmarks. Right over here, halfway between 1 and 1.5 is 1 and 1/4, which is 1.25, 1 and 25 hundredths. And halfway between 1.5 and 2 is 1 and 75 hundredths, 1 and 3/4. And then I can do exactly the same thing over here, 2.25 and 2.75. Now that I've filled in all of these benchmark numbers, it's fairly easy for me to place each one of these. So 2 and 3 thousandths is just a tiny bit more than 2, because this is really 2 and 250 thousandths right here. So this right here is going to go somewhere. Let me use a different color. This is going to go somewhere right in here. 2 and 3 thousandths. It's very, very, very close to 2. As a matter of fact, I can't really even get it that close to 2, the correct amount close to 2, but we're going to say it's just on the right side of the 2. 1 and 4 tenths, this one right here, is slightly less than 1 and 5 tenths. So this is 1 and 2 tenths and a half, so 2.5 tenths. Here's 1 and 4 tenths. I'm going to place it somewhere maybe right over here. 1 and 83 hundredths, this one. Here's 1 and 75 hundredths. So 1 and 83 hundredths is probably somewhere right in here. It's only, what, 8 hundredths more than 1 and 75 hundredths, so it's not that much more. I'm going to put it right about there. Again, I'm estimating here, so these are not going to be perfect. 2 and 9 tenths. Well, that's more than 2. It's more than 2 and 5 tenths. It's more than 2 and 7.5 tenths. It's really close to 3. So if 2 and 7.5 tenths is right here, there's maybe 2 and 8 tenths, 2 and 9 tenths, maybe right about here. approximately. And my last one is 2 and 537 thousandths. That's greater than 2 and 5 tenths. Here's 2 and 5 tenths. Matter of fact, this is 2 and 500 thousandths. 2 and 537 thousandths is slightly more. It's 37 thousandths more, so maybe somewhere right in there. 2 and 537 thousandths. Question 9. Let me move this up a little bit. Question 9 says, shade the given decimal or fraction below, and each of these pictures, each of these individual pictures represents one whole. So the first one asks us to shade 9 tenths. If this entire square here represents one whole, 9 tenths means 9 entire sections that are 10 hundredths long. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could also think of this as 90 hundredths, which is why I shaded in 9 sections of 10, or 90 out of 100. The next one says to shade in just 9 hundredths. So that means just shade in 9 of these little squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last one, it says to shade in 9 hundredths again, but this time the whole has changed. The whole is no longer a 10 by 10 grid. It's now a 10 by 10 by 10 cube. And that means we have 1,000 total little cubes here. And we are wanting to shade in 9 hundredths of those. But considering that the whole is out of 1,000, I'm going to make this be out of 1,000. So now we have shading in 90 thousandths, 90 out of the 1,000 cubes. So that means I need to shade in 90 cubes. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Notice that that looks very similar to this one right over here, but obviously they are not the same number because this is 90 thousandths and this is a completely different picture. The whole has changed here, and this is 90 hundredths or 9 tenths. And the last question on this page says, write the letter that best represents 4 tenths on the number line below, and then it's going to ask us, how do we know? So we've got 1/2 and 1 whole marked on here. I know that 1/2 as a decimal is the same thing as 5 tenths. So it looks to me like B is going to be greater than 5 tenths. I'm going to estimate that it's maybe 6 tenths. It looks like C is just a little bit less than 1 whole. I'm going to estimate it as maybe 9 tenths. And D is well more than a whole. It's maybe, if this is a tenth away, that's maybe 1 and maybe 3 tenths, something like that. Maybe 1 and 25 hundredths. But A is the only one that is less than 5 tenths, so it is the only one that makes any sense for 4 tenths. And I know that, again, because 1/2 is equal to 5 tenths, and 4 tenths is less than 5 tenths, and A is the only one to the left of 1/2. All right, moving on to page 2, question 11. Says, write the decimal that is exactly halfway between 3 and 5 hundredths and 3 and 6 hundredths on the number line below. So out to the side, I'm going to write my two numbers, 3 and 5 hundredths and 3 and 6 hundredths, and I'm looking for what is exactly halfway between those two decimals. So I'm going to need to go further. I need to put a 0 in the thousandths place. And once I put a 0 in the thousandths place, then I can see that in between 3 and 50 thousandths and 3 and 60 thousandths, there's another number hiding, and that's 3 and 55 thousandths in between there. So 3 and 55 thousandths is my number that is exactly halfway between them. Question 12 says, list all of the factors of 36. So when we're listing factors, we're looking for pairs of numbers that multiply to equal 36. So I'm going to start out with 1 and 36 because I know that every single number has 1 as a factor. And you can make this as a rainbow and connect them if you want to. Unfortunately, the way I have this written, or printed out. If I connect it with a rainbow, I'm going to run into these two problems below, so I'm not going to, but you can on your scratch paper if you want. After I've checked 1 and 36, or written down 1 and 36, now I'm going to check if this number is even, and it is. Because it's an even number, that tells me that 2 will definitely go into 36. I just need to know what I multiply 2 by to equal 36, and 2 times 18 is 36. If you weren't sure, out to the side you could have done 36 divided by 2 and quickly found out that 2 went into 36 18 times with no remainder. Next, I'm going to check 3, and if you're not sure if 3 will go into 36, again, do some division out to the side. 3 goes into 6 twice, so yes, it does go in with no remainder. So 3 goes in 12 times. 3 times 12 is 36. Next, I'm going to check 4, and that's just a basic math fact. 4 times 9 happens to be 36. Next, I'll check 5, and this number does not end in a 0 or 5, so I know 5 is not a factor. I know 6 is a factor because that's another basic math fact, and I know 6 times 6 is 36, so I'm going to put 6 right here in the middle because it's my last factor, and the reason that I know it's the last factor is because I can multiply it by itself to equal 36, so there's definitely nothing else there. So 36 is a special type of number. It's called a square number because it has an odd number of factors. We have some factors right here paired, 2 and 18, 3 and 12, 4 and 9, but then 6 is paired with itself, which gives us an odd number of factors, and we could form a square array, a 6 by 6 array from the number 36. Questions 13 and 14 says complete a factor tree for each number and then write the prime factorization for the number. So to do a factor tree, I'm going to split 63 up into two numbers that are factors of 63, and the ones that come off the top of my head are 9 times 7. You might have done 21 times 3. What you don't want to do is 63 times 1 because that's not going to help you, because then you're going to be right back to splitting up 63 again. Okay, now that I've written two factors of 63, I'm going to ask myself, are either of these prime? And 7 is, so I'm going to circle it. 9 is not, so I'm going to split it up. And two factors that equal 9 are 3 times 3. And 3 is prime, and this 3 is prime. So for the prime factorization, I have 3 times 3 times 7 should equal 63. We can check this. 3 times 3 is 9, and then 9 times 7 does equal 63, so I have checked this. I could also write this using exponents. 3 times 3 is the same thing as 3 squared, and then I could just do 3 squared times 7 also equals 63. Question 14 is 120, and the one that comes to my mind is 12 times 10. You could have done 60 times 2 or 40 times 3. There are quite a few things that you could have done for this one. Neither of these numbers, neither of these factors are prime, so I'm going to split them up. 12, I think of 4 times 3, but you could have done 6 times 2. And 10, I think of 5 times 2. 4 is not prime, but 3 is. 5 is prime, and 2 is prime, so I just need to split this 4 up. And I can split 4 into 2 times 2, and then 2 is prime. So I have 1, 2, 3 2's, 2 times 2 times 2, a 3, and a 5, and that should equal 120. I'm going to check. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 5, let's make sure that that's 20. 24 times 5, 120. 5 times 4 is 20, 10 and 2 is 12. Yep, that equals 120, so I have checked this. I could write this using exponents. Because I have 3 2's, I could say that that's the same thing as 2 to the third power, or 2 cubed, then times 1 3 and times 1 5. That is also equal to 120. Question 15 says 27 times 10 to the third, so we're trying to evaluate this expression. 10 to the third means 10 times 10 times 10. So that means 1 times 1 times 1 with 1, 2, 3 powers of 10. So 1, 2, 3 powers of 10. So 10 to the third is the same thing as 1,000. I want 27 times 1,000, which is 27,000. You could have also thought of this as 27 with 3 powers of 10. So 27, 1, 2, 3 powers of 10. Remember that when you multiply by a power of 10, you just shift a digit to the left. So number 16, we have 500, which is the same thing as 5 times 2 powers of 10, times 8,000, which is the same thing as 8 times 3 powers of 10. So if I just multiply the 5 times 8 first, I get 40. But then I need 2 plus 3, so I need altogether 5 more powers of 10. So 1, 2, 3, 4, 5. And I can go ahead and put in my commas, and I get 4 million. You could have written out all these, instead of using exponents here, we could have done it as 5 times 10 times 10, and 8 times 10 times 10 times 10, and then you could have just counted up the number, the tens. I used exponents just to save some time. And make sure that when you're doing this problem, 5 times 8 is 40. There is a power of 10 already in 40, but it comes from the 5 times 8, so it's not included in these powers of 10 right here. Question 17 is what number times 30 equals 21,000? So I know that this is 21 times 3 powers of 10. And I know that this 30 is 3 times 1 power of 10. And then I know that I have something multiplied by that. I don't know what that something is. So let's first figure out 3 times what is 21? And that's going to be 7. 3 times 7 is 21. So I know that there's going to be 7 over here somewhere. Now I need to find out how, if there are any powers of 10 and how many. So I end up with 3 tens over here, 3 powers of 10 over here. I have one right here. It looks like I'm going to need 2 more to keep this equation balanced, because if I have 3 powers of 10 over here, I need 3 powers of 10 on this side. So I'm going to need 2 more powers of 10 here, 2 more right here. And that would give me 7 times 10 to the second. So 2 plus 1 gives me 3 powers of 10. 7 times 3 is 21. Question 18 is the same type of problem. I have 4 times 2 powers of 10 times some mystery number equals 12 times 1, 2, 3, 4 powers of 10. So 4 times some mystery number equals 12. I know that part of that mystery number is a 3. I have 2 powers of 10 times some mystery number will end up giving me 4 powers of 10. So it looks like I need 2 powers of 10 and then 2 more. So 1, 2 more. So this could be 3 times 10 squared. So 4 times 3 is 12. 2 powers of 10 times 2 more powers of 10 gives me 4 powers of 10. So this is a 3 right there. Let's make that a little bit more clear. On number 19, let me move this up a little bit. 19 and 20, we are doing multiplication, but we're using the distributive property by partial products. And this would be an area model for partial products. On number 19, we've already written each of the factors in expanded form. So 64 is written as 60 and 4. I can think of this as a plus right here, and 38 is written as 30 plus 8. So altogether we have a 64 by 38 array, but we split that array into 4 partial products. This partial product, this array right here, is a 30 by 60 array. This array right here on the side is a 30, and the top is a 4. This array right down here is an 8 by 60 array, and this last array in the bottom right is an 8 by 4 array. Obviously they're not drawn to scale since they all look identical. So now we just need to multiply out these partial products. 3 times 6 is 18, and we have 1, 2 powers of 10. 3 times 4 is 12 with 1 power of 10. 8 times 6 is 48 with 1 power 10. And 8 times 4 is 32. And lastly, I'm going to add up my partial products. Make sure that you line everything up according to place value. So be careful, don't put this one that's in the hundreds place with this one that's in the thousands place. Once we line everything up according to place value, it's just an addition problem. 8, 9, 10, and 4 is 14. So I have a final answer of 2,432. Question 20 is the same thing, except that on question 20 we don't have the expanded form already written for us, so we're going to have to write it out. Looks like the top is going to be the 384 since it has 3 places. The 3 is worth 300. The 8 is worth 80. The 4 is worth 4. So there's my 384. Along the side, the 2 is worth 20. The 7 is worth 7. So now we have our area model set up for partial products. This top left box is a 20 by 300 array. So I'm going to write that really small, 20 times 300. This next one to the right is a 20 by 80. And the one on the far right, top right, is a 20 by 4. Going down to the bottom, we have a 7 by 300. This one here is 7 on the side, 300 on the top, so it's 7 by 300. This next one is a 7 by 80. And the last one is a 7 by 4. Go ahead and solve these partial products. 2 times 3 is 6 with 1, 2, 3 powers of 10. 2 times 8 is 16, 2 powers of 10. 2 times 4 is 8, 1 power of 10. 7 times 3 is 21 with 2 powers of 10. 7 times 8 is 56 with 1 power of 10. And 7 times 4 is 28. And lastly, let's add up our partial products, being careful to line up place values. You can do these in any order that you want, but I went ahead and just did them across and then down. 8 and nothing is 8. 8 and 2 is 10, and 6 is 16. 6, 7, 8 plus 5 is 13. 6, 7, 8, 9, 10. So we have an answer of 10,368. And the last two questions on this page ask you to estimate and solve, and they don't tell you any method to use. So you have your choice of methods. First thing I'm going to do is estimate. So I'm going to round 93 to 90. I'm looking for, when I'm rounding, I'm looking for a single digit in powers of 10. I'm going to round 467 all the way up to 500 because I want a single digit and some powers of 10. So notice I'm really rounding to the greatest place value. In this case I'm rounding to the tens, in this case I'm rounding to the hundreds. 9 times 5 is 45. 1, 2, 3 powers of 10. So in this first blank, that's what I'm going to put. 90 times 500 is 45,000. That's my estimate. Now I'm going to go ahead and solve, and I'm going to use traditional multiplication, which means I'm going to put the number that has the most digits on top, and I'm going to line up everything on the right hand side, ignoring place value, but in this case place value actually even lines it up. So now I'll start with 3 times 7, which is 21. I'll carry. 3 times 6 is 18, plus 2 more is 20, and carry. 3 times 4 is 12, plus 2 more is 14. And I'm finished with the ones place. So I'm going to put a 0 to make sure that I'm now multiplying by tens, and I'm done with these numbers that I carried. 9 times 7 is 63. 9 times 6 is 54, and 54 plus 6 is 60. 9 times 4 is 36, and 36 plus 6 is 42. Add up these two partial products. and I get 43,431. Compare that to my estimate, which was 45,000, and it's fairly close. So that's a reasonable answer. And question 22, I'm going to round 54 to the tens place, and that'll give me 50. I'm going to round 39 to the tens place, and that will be 40. 5 times 4 is 20. 2 more powers of 10. So my estimate is 50 times 40 equals 2,000. When I do the actual answer, I want to write, if I'm doing traditional multiplication, I want to write the factor that has more digits on top, but in this case they both have the same, so I can go ahead and start. 9 times 4 is 36. Carry the 3. 9 times 5 is 45, plus 3 more is 48. I'm done with the ones place, so I'm going to put a 0 to bump myself over to the tens place. 3 times 4 is 12. 3 times 5 is 15, plus 1, 16. Add these partial products. And I get 2,106. I'll compare that answer, 2,106 to 2,000. Again, very close. So this is a reasonable answer. Now beginning the third page with question number 23, which says estimate 457 and 5/10 plus 2 and 7/100. When you're estimating with addition and subtraction, we don't necessarily have to round to the greatest place value because we're not necessarily working with powers of 10. So usually what I do is I round to the least place value that I can still easily work with in my head. So in this case, if I were to round this to the hundreds, I would round it all the way up to 500. If I round it to the nearest 10, I would round it to 460. Round it to the nearest 1, I'd round it to 458 because that would bump up to 458. And this one, it looks like no matter what I'm going to do, I'm definitely going to round this one to 2. So in this case, if I round this to 458, I can work with that in my head. I can do 458 plus 2 and get 460 right there. But if you rounded this to 460 and did 460 plus 2 and got 462, you're not wrong. You're just not quite as accurate with your estimate. And if you rounded this to 500 plus 2, again, you're not necessarily wrong, but that's not the best estimate that you could have made. On number 24, same thing, except this one is subtraction. Looks to me like, again, the second one is the easier one for me to estimate right away. I'm definitely going to round that to 40. Considering that this is a very large number, I don't want to round this to 39 and have to subtract 39 in my head. But I can subtract 40 fairly easily because that's just 4 tenths. And this number is 1,598 and 2900ths. I know I'm not going to care about the 2900ths. The question is, do I want to round this to 1,000 to like 1,600 or 2,000? And in this case, if I round it to the nearest thousands place, it would go to 2,000. If I round it to the nearest hundreds, it would go to 1,600. And everywhere else, it's also going to go to 1,600. So I think I can work with 1,600 in my head. That kind of depends on you. If you think that you can easily subtract four groups of 10 in your head easily from 1,600, or if you think that would be easier to do from 2,000. I'm going to go ahead and do it this way. And I'm just going to count backwards by skip count by tens backwards. So that would be 1,590, 1,580, 1,570, and then 1,560. Question 25 says round this number 52 and 381/100ths to the nearest tenth. First thing I need to do is find the tenths place. There it is, the 3 right there. So if I were to zoom in on this, I have 52 and 3/10, definitely that I have. The next tenth up, way over here, would be 52 and 4/10. So these are my choices. I'm trying to decide, am I going to round this to 52 and the 3/10 that I already have, or the next tenth up, 52 and 4/10. So exactly halfway in between, if I put a 0 in the hundredths place, would be 52 and 35/100ths. Halfway between 30 and 40 hundredths would be 35 hundredths. And this one is 52 and 38 hundredths plus 1/1000th. So it looks like it's going to be 38 hundredths is going to be somewhere over here. So if this is my number, 52 and 381 thousandths, if it's right about here, we're definitely going to round up to 52 and 4/10. You could also look at this and say 52, and if I have 52 and 3/10, 8 hundredths is more than halfway to the next tenth, so therefore I'm going to round up to the next tenth. That's what this picture right here is showing, that halfway to the next tenth would be 5 hundredths, and we have 8 hundredths. 26 is round 2 and 56 hundredths to the nearest whole number. So that means we're rounding right here to the nearest whole. So we either have we definitely have 2 holes. The question is, are we closer to 3 holes? Halfway would be 2 1/2, 2 5/10. As a matter of fact, I can even make that 2 50 hundredths so that I could place this a little bit easier, which will be somewhere right about here. So it's more than half. It will round up to 3 holes. For questions 27 and 28, we're going to model each operation using the decimal squares, and then we're going to actually solve, and each of these 10 by 10 decimal squares represents 1 whole. So our first problem says 51 hundredths plus 63 hundredths. So the first thing I'm going to do is shade 51 hundredths, and that will give me, that means I'm going to have 5 tenths and 1 hundredth. So there's 5 tenths and 1 hundredth. And I'm also now going to do 6 tenths and 3 hundredths. And there's several ways you can do this. You could just start counting off 63 squares so that you do it all matched up. You could do it over here. It doesn't really matter as long as you are shading 63 squares, because we want 63 hundredths. I'm going to do it like this. Here's 9 10, so there's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, and now I want 3 hundredths. 1, 2, 3 hundredths. So I just put mine back to back, and now when I solve this, all together I have 1 full square. Looks like I have 1 full tenth, so 1 whole, 1 tenth, and 1, 2, 3, 4 hundredths. So I'm going to get 1 14 hundredths. On question 28, we're going to do 1 93 hundredths plus 1 73 hundredths. So I'm going to go ahead and start shading 1 whole. I'm just going to X this out. There's 1 whole. 93 hundredths is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 hundredths. 1, 2, 3. And now I need 1 73 hundredths. I'm going to go ahead and do my 1 whole right here, and then I'm going to fill in my 73 hundredths. So I need 7 tenths. So here there's 7, 8, 9, 10. There's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, and I want 3 hundredths. 1, 2, 3. So there's my 1 73 hundredths. Now I need to figure out what I have all together. I have 1 whole, 2 holes, 3 holes, 1, 2, 3, 4, 5, 6 full tenths, and 1, 2, 3, 4, 5, 6 hundredths. 3 66 hundredths. Question 29 and 29 through 32 actually all say just solve and show all your work. And it looks like these are all going to be addition and subtraction with decimals. And anytime you're doing addition and subtraction with decimals, the most important thing that you need to do is line up your place values. So I recommend you find the ones place in each one of your numbers and then line up the ones. The decimal point and everything after it will take care of itself if you line up the ones place. So here's your decimal point, so there it is right here. Fill in the empty place value, and then we can go ahead and add 5, 6, 7. We have 75 and 4 tenths. Excuse me. Do the same thing on number 30. Here's your ones place. There's your ones place. I'm going to go ahead and write down 32 and 38 thousandths. And I'm going to put the 3 from this one right below the 2 because they're both in the ones. And then fill in empty place values and add. And I've got 35 and 758 thousandths. Moving on to number 31, we have subtraction now, but we're doing exactly the same thing. Find the ones place. And we're starting out with 82 and 36 hundredths, and we're taking away 17 from that. So the 7 is going to line up with the 2. And notice that after the 7 now is going to be the decimal, because hiding after every whole number is a decimal point. And now we can subtract. We can't do 2 minus 7 without going into negatives. So I'm going to have to do some regrouping. So this becomes a 12. 12 minus 7 is 5. 7 minus 1 is 6. 65 and 36 hundredths. And the last problem of these type, find the ones place. Ones place with your decimal numbers is always just to the left of the decimal point. Line up the 5 with the 0. And now we need to fill in empty place values because we can't take 9 away from nothing. So it looks like there's going to be quite a bit of regrouping going on here. So way over here becomes a 0, this becomes a 10 and then a 9, 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 and lastly a 10 because there's nothing regrouping from this place value. So now we can subtract 10 minus 9, 9 minus 9, 9 minus 9, 9 minus 5, 9, 9. So our answer is 994 and 1 thousandth. And the last two problems on this page say solve using extended division facts. So that means you shouldn't have to work these out. We're just using powers of 10. This is really 42 times 2 powers of 10 divided by 7 times 2 powers of 10. We can do 42 divided by 7 first. That gives us 6. And then our 2 powers of 10, 2 tens, this is really this, 10 times 10 divided by 10 times 10. If we divide 10 times 10, 100, divided by 100, we get 1. So 6 times 1 is just going to be 6. So there's our answer, 6. Over here, we can divide 24 divided by 8, which is 3. And then we have 3 powers of 10 divided by 1. This really means 10 divided by 10, which is 1. So I can just cancel them out. And I have 2 powers of 10 left that are going to be in my answer. Again, this was this. 24 times 3 powers of 10 divided by 8 times 1 power of 10. 24 divided by 8 is 3. 10 times 10 times 10. And then we're dividing by 1/10, so this last 10 divided by 10 was 1. So 10 times 10 times 1 is 100. That's why we have these 2 zeros right here. And now to our last page, beginning with question 35. It says estimate and solve. So to estimate first, when I'm estimating with division, I always start with a divisor. And I want to round this to the greatest place value possible, which in this case is going to be 20, the tens place. And I'm going to look at the 2, and I want to look at something over here, the first few digits that are going to be a multiple of 2. In this case, I'm just going to look at the 8 because that's already a multiple of 2. So I'm going to leave the 8 alone, and the other 3 digits I'm going to change to zeros because now I know I have an extended division fact that I can work with. I know I have 8 divided by 2, and I can do that and get 4. And then I have powers of 10. 10 divided by 10 is 1, so 2 powers of 10 left. So my estimate was 8,000 divided by 20 equals 400. And now I'm ready to do my long division. So my dividend is 8,314, and I'm dividing by 16. I know 16 doesn't go into 8, but I don't really know my 16s, so I'm going to quickly start making me a list. 2 16s is 32. 3 16s is 48, and 4 16s is 64. If you don't know, if you can't easily skip count by 16 in your head, then you're going to need to do something like this and actually write it out. So 5/16 is going to be 80, and 6/16 will be 96. I'm going to stop right there because I have 83, and I know that I can't have more. I can't make 6 groups from 83 because that would take 96. So I'm going to make 5 groups of 16. That uses up 80 of what I had. Of course, this isn't really 80 based on place value, but for right now, we're going to just call it 80. 83 minus 80 is 3. We'll regroup. And with 31 here, I can't even make 2 groups, so I'm just going to make 1 group. Do some regrouping here. And bring down the 4. And now I have to go all the way to 154. I'm kind of guessing that's maybe 9 times. So I'm thinking out to the side, I'm just going to do 16 times 9. 6 times 9 is 54. 9 plus 5 is 14. Yep, that's 144. So it's definitely going to be 9 times. And then I'm going to even have a remainder. And it looks like my remainder is going to be 10. So I'm going to have 519 and 10 leftovers that I'm trying to divide into 6 groups of 16. 519 and 10/16. Question 36. I'm going to go ahead and estimate. When I'm estimating here, I start with a divisor, but in this case, I know my 4s, so I'm going to leave the 4 alone. And I also know that 4 goes into 4, so I'm going to leave that 4 alone and change all of these to zeros. 4,000 divided by 4 I could probably do in my head. It is 1,000. Go ahead and writing my dividend and divisor. 4 goes into 4 one time. Be careful here, 4 does not go into 0, so I must put a 0 up here above the 0 that I just regrouped with. Now I can regroup with the 3. 4 also does not go into 3, so I must put a 0. And then finally bring the 2 down. 4 goes into 32 8 times, and I'll have no remainder, so my answer is 1,008. Again, anytime you're doing estimates and actual answers, make sure you're comparing your actual answer to your estimate, your actual answer to your estimate, to see if they are reasonable. Now keep in mind, this one right here is going to be, it looks like it's fairly, it's off quite a bit, but consider that we did round quite a bit here. Whereas on this one, we didn't round the 4 at all, and we only rounded this down by 32. So this is going to be a much more accurate estimate than this one is right here. Question 37 is a word problem. It says Union 5th graders attended a music recruitment concert in December. There were 1,173 5th graders, and buses can hold 45 students, so how many buses were needed? So I'm going to take my 1,173 5th graders, and I'm going to divide them into groups of 45. Those groups of 45 each represent 1 bus. 45 does not go into 1 or 11, but it goes into 117. I'm going to guess twice, but I'm going to make a list of 45s really quickly. Looks like that's going to be 135, so it's definitely going to be twice. Make sure you do regrouping here. And now we have 273. So 45 will go into 273 how many times? Now you can either continue your list by skip counting by 45s, or you can try to do some side multiplication. And I'm going to estimate, I'm going to say maybe 7 times, and I'm going to try that. 7 times 5 is 35. 28 and 3 is 31. It looks like that's too much, so let's try 6 times. 24 and 3 is 27, and that's really close, so it looks like it's going to be 6 times. Now the question says how many buses were needed. We know we need 26 buses, but we have 3 students, these were students, who are left over. Those students need to go on this field trip, so we must round up to 27 buses. Question 38 says GameStop is selling video games for $9 each. If Tyler has $40, how many video games can he buy? So we're taking the $40 and we're splitting it into groups of 9. Now notice I did not make $40 look like money because I'm not looking for a money answer. I'm looking for how many video games he can buy. So I don't want a decimal answer. I can't buy a decimal part of a video game. So 9 doesn't go into 4, it goes into 40 4 times. So I definitely can buy 4 video games, and the question is, what does this leftover actually represent? Well, this 40 was originally dollars, so this 4 represents $4 left over. $4 is not enough to buy a video game because they cost $9 each, so I'm just going to have to save this $4 or spend it on something else. All I can buy is 4 video games. So in this case, I was ignoring the remainder. Question 39 says, use the data set below to find each landmark. So we're going to use all these numbers. We're going to find the mean, median, mode, and range. The first thing I'm going to do is put all of my numbers in order from least to greatest. So I'm going to just mark them out as I go. 46 is the minimum. Looks like 74 is the next. Then 80. Then 85 twice. Then 90, and then 100. So now that I've got my data in order from least to greatest, it makes it much easier for me to figure out the median, mode, and range. I'm going to start with the one I think is the easiest, which is the mode, because the mode is just which number occurs most often, which is 85. The range is asking me to figure out how spread out my data is. So what I need to find out is how far apart is the maximum and the minimum. So I'm going to take 100, subtract 46, and that will tell me the difference between the maximum and the minimum. And it looks like the difference is 54. So my data is pretty well spread out. The median is the number in the middle that will separate my data into 2 halves. So what I'm going to do is I'm going to mark out the biggest and the smallest, the biggest and the smallest, the biggest and the smallest, and there is my median, 85. The mean is the one that's going to take the most work, because what I need to do is level out all of this data. Now I can either take one away from here and put one over here, and then take one away from here and put it over here, and keep doing that over and over again, or I can just combine all of my data by adding all of it into one huge pile and then dividing it into equal groups. So that's what I'm going to do, is I'm going to add up all of my data over here. And this is where the associative property comes into handy, because you can group this, when you're adding this up, you can group it with the 6 and the 4, which is a 10, and 5 and a 5, which is 10, so that's 20. Let's see, 8 and 8 is 16, and 4, that's 20. 8 and 2 is 10, so that's 30. Plus 9 is 39. 39 and 7 is 46. So I have 560. That is not the mean, though. That's my big stack of whatever these, if you want to call them points or numbers or whatever, that's all of these combined. We have 1, 2, 3, 4, 5, 6, 7 pieces of data that we need to level out. So I'm going to divide by 7. 7 does not go into 0, so it looks like the mean, the leveling out point, is 80. Question 40 says, give an example of each property of addition or multiplication. So the commutative property is turnaround facts. It says that if I take a number and I add another number to it, I can do the same thing in reverse. That the order does not matter. 3 plus 4 is the same thing as 4 plus 3, and that also works with multiplication. 3 times 4 is the same thing as 4 times 3. The associative property is a grouping property. It says that if I'm trying to add 3 numbers or more, I can group it like this and add the 3 plus 4 first, or I could group it like this and add the 4 plus 5 first. And I actually did that right over here. I decided to do 6 plus 4 first, and then 5 plus 5, and so on. This also works with multiplication, so if I change these to multiplication signs, it would work exactly the same way. So the associative property is your grouping property. And the identity property says that when I take a number, let's say 4, and I add nothing to it, I get the same number. So there's the identity property of addition, and the identity property of multiplication says when I take a number and I multiply it by 1, I get the same number. The distributive property means I'm going to take this 2 and I'm going to distribute it to everything in the parentheses. So I want 2 x's, and 2 5s, and 2 5s. 2 5s would be what, 10? So simplified would be 2 x's plus 10. You could also think of this as x plus 5, what's in the parentheses, this variable x plus 5, twice x plus 5. If we add up these two x plus 5s, we get 2 x's and 10.